Artificial intelligence. We are trying to mimic the human intelligence. So, are we able to achieve that? So, if not, what are the limitations? So, the topic here is AI a limited version of intelligence? The agenda of this talk is automation versus intelligence. How do we measure intelligence? What is the test, Turing test, types of AI, and the components of AI. Automation doesn't necessarily mean that it is including intelligence. It can be a sequence of actions which is repeatedly done, which can be processed or which can be compiled beforehand. So the automated lifestyles, for example, the smart home control, air conditioning systems, automated coffee machine, then the Alexa, the Zomato or the Swiggy delivery. These are all automation. That means it doesn't need any intelligence, even there is no uncertainty involved. All it is deterministic. And we are processing with a minimal human intervention. Now coming to the artificial intelligence, it has been around since 1950s and it's a science of teaching programs and machines to complete the tasks. The machines are being made intelligent by doing programming, by making the machine learn using training, and then we test it by giving them new data and we check whether the human intelligence, what we require, is being met by the programs or not. The advancements in the AI has accelerated in the past decade because of these three factors. One is the rise in the computing power, as it is highly computational complex and the data driven. So availability of data is very high now because each and every process we are able to capture the data by the digitification and improvements in the machine learning algorithms. The intelligence, when we are trying to imbibe intelligence, then the thinking, acting, it's not only thinking humanly but thinking rationally and accordingly acting humanly and acting rationally. So such type of agents are called rational agents which can act rationally, think rationally. Now what are the key qualities a machine should have to pass this intelligence test? The Turing test is the intelligence test. So if a machine passes the Turing test, we can say that it has achieved the human intelligence. So far, it has not been achieved. So in this Turing test, if we see, there is a computer player A and a versus the human responder player B. And there is an interrogator player C. So if the interrogator will pose a question by typing and the answers will be provided by the computer player A and the human responder. The interrogator player C has to guess whether the answer has come from a human or from a computer. In this game, if an interrogator would not be able to identify which one is human and which one is machine, then the computer passes test successfully and machine is said to be an intelligent similar to a human. This is another diagram, visualization of a Venn diagram, the Turing test, which is the test of intelligence. The Turing test is the intersection point which is purple in color. Humans can display intelligent behavior as well as unintelligent behavior because humans we are able to compute the IQ level of any human, and not necessarily every human is having a very high intelligent IQ. So we are having a capacity of not, for example, not doing a lot of calculations in fraction of seconds. That is not the ability. So such type of intelligent behavior are not displayed by humans. Whereas this ultra fast complex mathematical calculations are very common with the machines, but they are not intelligent enough like humans when we are thinking and acting rationally in cases of uncertainty or decision making. So this purple intersection is the test of intelligence, and if it is being passed, then we can say that the machines have also achieved the intelligence of human. Now, areas of the artificial intelligence where we need to work, we need to do research in order to make the computer win this Turing test. The communication, which is the natural language processing. When the interrogator is typing the questions, it has to be in a general human language, and the computer should be able to interpret the semantic, the meaning of the question being asked. So the communication introduces a field of AI, which is natural language processing. Now, how to store and retrieve the information during the test? So this is a knowledge representation. Effective knowledge representation is very important for the retrieval of the messages as well as for the storing. Automated reasoning, another field where the previously stored information, for answering the questions, the reasoning has to be done, the logical reasoning has to be done. Machine learning, so which adapts to new changes, learns, relearns. There are the types of machine learning where supervised, unsupervised, reinforcement type of machine learning are there, and it tries to find out the pattern, and it tries to find out the generalization of the input data. And while learning it, you can give a test. So after learning, the test is given so that it is able to whether it has been able to accomplish the task or not. Coming to the vision, which is also called total Turing test. Previously in Turing test, we were showing that the interrogator was typing. Here we are able to see, visualize also. So vision. So this is the computer vision, where it is in recognizing the interrogator actions and other objects during a test by seeing. So it's after seeing, the brain processes and makes a decision, and then acts. So this is the vision part. The computer vision is also a very hot topic in the areas of AI. Finally, for total Turing test, when we act upon an object and act upon for doing the task, for performing the task, then like robotics is the motor control. So the robotics part comes under the motor control. So that part of the AI is also, lot of research is being done. Major components of the AI: knowledge representation, the common sense rule which helps us in reasoning, communicating by using the language understanding in a natural way, that is the natural language understanding, and learning, adapting to the new changes and gaining the skills. The AI has evolved, and there is basically, initially it was automation, which is hardly having any intelligence, as I initially told. Now coming to the intelligence, there are two types of artificial intelligence: weak AI and strong AI. Weak AI is also known as narrow AI. Narrow means we are fixed, that it works only for a specific task. Say for example, it can only do in the intelligence is only in making decision for, say for example, when you are taking a photograph and it detects the faces, and so that it's not blurred, it is coming focused, that part. So this part of intelligence, when embedded in this camera, will only work for the camera. It doesn't work for any other application. So it is a fixed type of task, and the intelligence software or machine learning is embedded only for that particular task. Whereas general AI or the strong AI refers to human level intelligence, which is able to transfer knowledge between domains. So between domains means now when as a human I am driving, so I am having the intelligence to drive, not to have any accident, drive safely. Once I reach office, the domain changes to the specific to my office task, where uncertainty may happen, but I try to learn from my previous experience and take decisions. This is different from the driving domain. The same person is showing intelligence in the office field. Now once I go back home, there I am using my intelligence to do household work. So across the domains, the knowledge is transferred, and you can see such type of behavior, you can see it in the sci-fi movies, but that is only in the movies. It is not in the real world. A robot who is like a human and across the domains is able to drive, is able to do the household work, office work, everything. So nowadays, whatever the robot is there, it does only a specific task, is meant to have intelligence only narrowing down to a specific task. So we are here, that tag is mentioned because presently we have achieved till the weak AI, and it will take a couple of or more than 2-3 decades to come to the strong AI. These are some of the examples, which is the weak AI and which is the strong AI. So there's this digital voice assistant, Siri or Alexa. So there is a scope on which the Alexa can reply. It cannot reply each and everything. After when you are asking in different language, in some Indian language, maybe it will stop. It will say, I don't understand. Then recommendation engines, Netflix is having a specific storage on which it has been made to learn. So out of that, if you are coming out of that storage data, it may not be able to recommend. Then this is the ability to reason, whether this is ethical or whether this is not ethical. So this is actually a strong AI. So before that, what we were discussing about digital voice assistant, recommendation engines, these are weak AI. Consciousness, when there is a signal which is red and it just turns green, I start driving, but I see a pedestrian crossing the road. So then my consciousness and ability to reason, which is a strong AI, tells me though it is green, the signal is green, but I should stop so that the person doesn't get hit. So these type of intelligence have not been embedded in our machines as yet. Coming to the chatbots, that is also an example of weak AI, because it takes care of question answering in the scope of that e-commerce store. So if it is a jewelry store, it will be trained in such a manner that it can only reply on that context. It won't be able to reply for higher education, university level questions. Autonomous vehicles, till date, it doesn't possess any full cognitive abilities. As I told you in the example, it is having the computer vision part. When you are putting it in the reverse gear, you are able to see it is beeping when it is able to it's finding out some objects. So this type of this type of intelligence has been embedded, but the consciousness and ability to reason it's still yet to happen. Robots, drones, delivery bots, everything is again an example of a weak AI. The capability of reading needs, emotions is an example again of the strong AI. So this is what is the answer. The weak AI and the strong AI examples. Machines will have consciousness and decision making skills. Then we say it's full human cognitive abilities. That makes the machine equivalent to that of the human intelligence. Then we can say it passes total Turing test, and that's the future of AI. This is some of the examples of the weak AI: digital voice assistants, recommendation engines, search engines, chatbots, predictive maintenance analytics, robotics. So these are not having a mind conscious ability to reason. So that's why this is weak AI. And the strong AI, ability to reason, having common sense, consciousness, emotions, able to understand the emotions and generalize the knowledge, apply it to different domains, the knowledge transfer across the various domains where you are having full human cognitive abilities. That is the strong AI, which is the future. What does AI comprise of? The AI is the umbrella, the bigger umbrella. Inside that there's machine learning. So it's basically started with, the AI started with many subjects, like where you had statistics, logical reasoning, your psychology, and electronics, the machinery, computer science, algorithms. So these are early AI. Now slowly the programs are no more deterministic, and we are trying to create a model which can learn. So we give the data, the model learns from the data and becomes intelligent. So this learning is a part of the machine learning, which is a subset of AI. Next comes the deep learning, which has made a breakthrough in the world of artificial intelligence. That is another set of algorithms which mimic the human brain. So this is all related to the neural network. So this is the bigger picture of the AI. These are examples where we move from no AI to the AI using the deep learning. So when the AI, before that it was only basic descriptive and diagnostic statistics, and slowly we moved to predictive and prescriptive statistics, and finally we are coming out with the cognitive technologies when it is coming to the deep learning. Data analytics. Okay, so this is in that AI world. If I show that in the AI world, finally data is the king. When we try to learn from our previous experience also, we need a data, correct? So when the data is there, the data also goes through different stages. So initially it is a raw data, and we want to clean the data first to know the correct data which will be helpful for us to give us the insights. So what has happened? From the outcome of the data, we want to know, that is the descriptive. Why did it happen? I want to diagnose. So this is diagnostic analytics. What will happen next? That is the predictive analytics. And how can we make it happen? That is the prescriptive analytics. So these four aspects are very important in the field of data analytics. So this is an example of the predictive, where weather forecast is there, the tour packaging, hotel booking, stock market, and whether the disease will be prevalent in the coming months or it will reduce in the city. All these are planning prediction. Now this gives you a clear picture how the data science is coupled with the whole AI. So here we are taking the data separately and showing it as one of the important aspect, which is tightly coupled with whether it's AI, ML or DL. So these are the various applications of AI. So in the expert systems, speech processing, robotics, natural language processing, where you have the question answering, machine translation, text generation, content extraction, image recognition, machine vision. These are some of the examples of the AI. These are the references, the two books, Tom Mitchell's Stephen Lucy. Thank you.